Hi everyone, I'm Justin Joseph, and I work as a staff AI engineer for analog devices at the European Research and Development Centre in Ireland. Today, we will be going through 4 enterprise capstone projects built on datasets simulated from industry use cases, not academic exercises, not toy demos. All 4 follow the same hub and spoke architecture, where you have an orchestrator coordinating specialized agents, each operating within defined governance boundaries. Let me walk you through the architectural thinking behind each one. Your financial institutions live under constant regulatory change. RBI circulars, IRDAI guidelines, which evolve monthly. Today, compliance teams manually monitor the updates. They map the requirements to internal policies, they identify the gaps, and then they document everything for auditors. And this takes weeks. By the time they finish, the regulations have changed again. The system that we are discussing has 4 specialized agents. A monitor agent that tracks regulatory updates and prioritizes by impact. A parser agent that converts regulatory PDFs into structured requirements. A gap analyzer that compares those requirements against internal policies and scores each gap. And finally, a reporter agent that generates audit-ready compliance reports. The orchestrator manages workflow state and priority across the pipeline. Now, let's deep dive into the governance. We have 4 governance patterns. Pattern 1, citation tracking. Every compliance decision the system makes traces back to the exact regulation ID, the page number, paragraph, and clause. Not the AI determined this, but rather a traceable, auditable chain. When an auditor asks why something was flagged, the answer is specific and it is verifiable. Pattern 2, the knowledge graph. The knowledge graph visualization or the compliant knowledge graph is used for this. You have regulations, requirements, policies, controls, etc. structured as nodes in the knowledge graph. The relationship between the nodes, which for example are satisfies, references, supersedes, etc., which connects the individual nodes are the edges. And when someone asks, what happens if regulation 4.2.1 changes? You traverse the graph and you see every downstream impact in seconds, not a week-long manual review. And this is what impact analysis looks like when it is architected properly. Pattern 3, your human-in-the-loop gates. And these are the approval gates. The system does not make autonomous compliance decisions. It generates recommendations, it surfaces them for expert review, and the compliance officer approves or rejects, with timestamps and rationale captured. This pattern is non-negotiable in regulated industries, whereby you won't be having any black boxes. And pattern number 4, your audit trail. Every reasoning chain is logged. Which agent processed what, which tools were called, what the intermediate outputs were, and what the final decision was. And this is what we call as explainable AI. And this is how explainable AI looks like in a compliance context. You work with 22 real documents, IRDAI guidelines, MAS regulatory framework, and internal risk and governance policies. And that was project number 1. And for project number 2, a clinical intelligence system for healthcare. Now, the key architectural decision in project number 2 is hybrid search. You have medical records or medical data, which needs both semantic retrieval and structured keyword filtering. Now, vector search, if done alone, will miss these exact lab values, which are in the structured keywords. Now, the system also uses a reflection loop, where every response is validated against critical guidelines before it reaches a clinic. If confidence is low, it pulls more context rather than guessing. Access control is enforced at the orchestrator level. Your physician, your nurse, and admin each see only what their role permits. So, for example, an admin does not require to see everything that the physician or the nurse sees, because an admin's job is just administration. And this isn't a feature bolted for later. It is an architectural constraint that you will be enforcing from day one. and every interaction is traced through LangFuse for full auditability. You will have 39 clinical documents to work on this. E-commerce competitive intelligence. And this architectural pattern is agent-driven tool use. Now, your agents automatically decide or autonomously decide when to call external tools. Margin calculators, inventory checks, demand models, rather than following a certain hard-coded logic. Now, what makes this interesting from a governance perspective is the cost observability layer. Every query tracks spend per agent. Scouts cost $0.12 per query, analysts $0.08, strategists $0.15. You learn to evaluate the cost to value ratio across a multi-agent system, and you learn to route to GPT-4o versus GPT-4o mini based on the task complexity, which is your model selection strategy, which is a critical architectural decision for controlling AI spend at scale. And you will be having 60 plus SKUs across multiple product categories. Your project for supply chain contract intelligence. And this is following a retrieval architecture, which is GraphRAG. And GraphRAG combines your semantic search with graph-based queries, where your semantic search finds relevant clauses by meaning, and your graph queries understand contractual relationships, which obligations connect to which parties under which terms. Now, together, they outperform either of these approaches alone. And the system uses queue-based scaling through Celery and Kafka. When you need to process 500 contracts during an M&A due diligence, the architecture handles it without any redesign. An external signal monitoring layer watches for disruption events. A supplier news alert automatically triggers risk assessment across contract graph, and all the extracted data follows validated pydantic schemas, parties, dates, values, SLAs, liability, ensuring a clean integration with downstream ERPs and contract management systems. You will use 36 enterprise contracts across IT, consulting, and manufacturing for this. So there's 4 enterprise systems across 4 industries. Real governance challenges, real architectural decisions. And if you want to architect and evaluate systems like this, book a call with your program advisor. Thank you and have a great day.